So today we're going to find the confidence interval for a population mean. What's different from yesterday is yesterday we talked about a proportion, which you either had a yes or no answer, did you like it or not. Today you're having some sort of score, some sort of number that you're given. So this part right here is different from yesterday. Everything else is pretty much the same thing. So this is the equation we're going to be using today. So let's define all the terms in the equation first. The first thing is x bar, which we said previously was the mean. Okay. The next thing is the z of c, which it depends on the confidence interval, but if they say 90%, 95, or 99, you'll be using these numbers respectively. And then this is standard deviation. We've defined that before. And then the last one is n, which is our sample size, or the number of students or people in the sample, whatever you're sampling. Okay. So all this information will be given in the problem. We'll just be plugging it in to find what that mean is, and what the population mean is in between. So going on to our example, in a random sample of 20 students, so let's mark that because we're going to need that. At a large high school, the mean score is 610. Given that the standard deviation of all scores is 120, so that's our standard deviation, and a 99% confidence interval for the mean score among the students at the school. So we want to find a 99%. So what's they give us? They give us n as 20. Then they give us that the mean is 610. Then they tell us that the standard deviation is 120. And then they also tell us they want a 99% confidence interval. That's our z of c. And using this previous page back here, right here, we have 99% is 2.576. So I'm going to go back over here, and z of c is going to be 2.576. So what I'm going to do is I'm going to plug all this into my equation. So here's the thing, is I really only need to find one side at a time, because really it's the same thing except for the plus and minus. So once I find this side and I find my two values here and here, then it's going to be the same thing on the other side. It's just going to be plus. So I'm going to plug in just on one side. My mean is 610. My z of c we said was 2.567, or 576, sorry. And then my standard deviation is 120. And my sample size is 20 students. Okay. So I'm going to just solve this here. So I'm going to do 120. I'm going to do this part first. Okay. 120 divided by square root of 20 comes out to be 26.833. And I'm going to times that by the 2.576. And then that's going to end up being, minus 2.576 times 26.833 is going to be 69.122. And then I'm going to subtract those, and I get 540.878. Now I don't want to leave the decimal there like that, so I'm just going to round to 541. Okay, that's my low end. That's the lowest the mean could be. So we're talking about this mean score. The thing is, if I plug everything back in here, I really only need this 610 minus, we figured all of this out to be 69.122. So I'm just going to put that on this side, but it's plus now. So 610 plus 69.122 would be 679.122. So that's my high side. So once I find this out here, I really just need to add it to the 610 now. So it's 679. If I round it, can be my highest. So what this is saying is my mean, my population mean will be between 541 and 679. This is my solution right here. Oops, let's undo that. I didn't do a very good square there, did I? Oh, sorry. Okay. This here is my solution between 541 and 679.